Welcome to Lesson 6 of Geometry. So a coordinate plane is also known as a Cartesian plane, and it's a number plane or a grid developed by René Descartes, and it's done using the XY coordinate system. So in your XY coordinate system, that system of two numbers is called an ordered pair, and X always comes first and then Y. Now X is here and is your horizontal line, and Y is your vertical line. The middle point here is called the origin, and it's also your point of reference, and you'll often see it labeled as O or 0. And on your number lines and your scales, that origin is also always 0. How you draw these two lines together is to draw the one and then the other so that they bisect each other perpendicularly. And when they do that, you end up with essentially a number line going this way, a number line going up, and then extending down into the negatives this way. Now remember, when you're drawing your grids, that scale is also important. And so if you look at this particular scale, it's going up by 1. So even though it's going 2, 4, 6, if you look at the lines here, you know that the scale itself is actually going up by 1. So 1, 2, 3, 4. And same here, 1, 2, 3, and 4. When you look at your coordinate grid, when you draw all four sections, you end up essentially with 4 quadrants. These 4 quadrants start here in the upper right-hand corner and then proceed counterclockwise. So this would be quadrant 1, 2, 3, and 4. Now each quadrant has positive or negative numbers assigned to it, or in some cases both. So quadrant 1 is a positive number system, because if you go this way on the line, you're going positively towards X, and if you go up, you're positively into Y. So it is a positive coordinate system. Quadrant 2 is a negative positive, because if you're going to the left on this horizontal number line, you're going into the negative numbers. And again, you're still going up, so you're still positive into the Y. 3 is negative, because you're negative on the horizontal and negative on the vertical. And therefore 4 would be a positive negative, because you're positive on the X and negative on the Y. These are easy if you think about these as individual number lines, and if you remember from our algebra units, a horizontal number line with 0 at the center, or a vertical number line, which we use for temperatures, with 0 at the center. So it would be easier to remember where your negative sides are if you think about them in that manner. When you plot your points, you can use this two-dimensional plane to plot and identify any points. So to help us identify particular points, we use capital letters to refer to them. So in this example, A here, which is point 1, 3. So you go to the right 1 and then up 3 and put your point there. B at 4 and -1, and C at -2, -7. We can say here that if we look at this particular point here, that A, we can say that 1 is the X coordinate of point A and 3 is the Y coordinate of point A. So in order to plot this point, as I said, you start here and move up. Always do your X first. Alright, so for this one, for 4, you would go to 4 and then do -1. For this one, go to -2 and then down -7. So always plot or start your plot from your X coordinate. So this point, D, I would like you to write down what this particular coordinate set is for this point, and I will check that in class next class. So the next thing we want to look at is linear relations. And we did this in algebra a little bit. So if we take a look at this pattern down here, and we notice that to continue our pattern, 2 more dots need to be added each time. So we have 5 dots here, and then 7 and 9. So if we construct a table, an input-output table, where n is our number pattern, so 1, 2, and 3, and the number of dots in each of those patterns is p, 5, 7, and 9, we can create an equation where p equals 2n plus 3. So 2n here would be 2, plus 3 would be 5. 2n here would be 4, plus 3 is 7. 2n here would be 6, plus 3 is 9. So since the number of dots depends on this number, we say that n is our independent variable and that p is our dependent variable. And remember that our independent variable is always plotted on our x-axis, and so it is always listed first in our ordered pair. So the ordered pair for this would be 1, 5, 2, 7, 3, 9. Independent and dependent. So when you plot those ordered pairs and they end up in a straight line like this, 1, 3, 2, 5, 3, 7, 4, 9, you end up with a straight line. And we call this a linear relationship. And because the points are all on the same line, we say that they are collinear, just like when we talked about our points on our line segments. So you need to examine your data carefully and what kind of data are you using to create your table and to create your graph to determine whether or not you would connect these points with a line in between. Based on our table from the last screen, because it was an n value and a p value and there was no real data given, you can't say that you could go into the negatives here because a negative value isn't offered on this particular graph. And you also can't say that there is a half a point there. So in that case, because there can be no in-between data or data that extends past 0, we wouldn't draw a line through here to say that that data is continuous. However, again, if you were dealing with something like time, where time can be in seconds or minutes or in hours, you could connect those dots with a line to show that there could indeed be something happening in between. So, if we consider this equation, y equals x minus 2, okay? This describes the relationship between variables, x and y. So what this is essentially saying is that y equals x minus 2. So whatever the value is of x minus 2 is going to give you your value of y. So once you've done that, so using these values of x, and you create this input-output table of values, you then have your input-output in ordered pairs of -3, -5, -2, -4, -1, -3, and so on. So because this value of y is dependent on what this value of x is, that makes x our independent variable and our y the dependent variable. So once again, these values make up a continuous straight line, but because any value of x would give you a value of y, we would connect this with the line with the arrows in both directions, showing that this particular data set and the number values for x and y could be infinite and that they could go anywhere. So this then becomes the equation of this line. Okay? So it connects all of the points on this line. In algebra that we did at the beginning, we would call this the rule. Or if y equals x minus 2, y then is 2 less than the value of x. Whereas in algebra we would say y is 2 less than the number. So the last thing that we want to look at is the gradient or slope of the line. So gradient is the comparison of the horizontal step to the vertical step. So how far you're going across versus how far you're going up. So when you're calculating the gradient of your slope, it's wise to first move along the horizontal axis in the positive direction. So we start here and move to the right, start here and move up. And then when you're actually going to do the calculation, it is the vertical step divided by the horizontal step. And we use gradient or slope to measure the line steepness. And the horizontal line, so that's a straight horizontal line, is considered to have a 0 gradient. So as we go from left to right along each line, the line from A to B here goes up, well, up this way, and as we go this way, the line goes down. And so we say that AB has an upwards gradient and that CD has a downward gradient. Upward sloping lines are considered positive and downward sloping lines are considered negative. So if we went back to this one, as from left to right and up, we would say that this line is a positive gradient. Okay, so make sure you take some notes on this stuff and we will talk more about it in class.